Hello my dear students, I warmly welcome you to CR Digital Classes. In this video, we are going to solve the introduction. We are going to see the introduction of our topic, progressions. So basically, what is this progression and how many types of progressions that will be asked in our exam. So let us see. So first type of progression that is asked in our exam is arithmetic progression. So what is this arithmetic progression? Let us see. An arithmetic progression is a sequence of numbers such that the difference between the consecutive numbers is constant. He is saying that the difference between any two consecutive numbers is constant. So for suppose I have numbers like this. The first number is A and the second number will be what? Or for suppose let us take I have the first number as 1, the second number as 3 and the second number as 5, then 7. So the arithmetic progression is nothing but whenever the difference between two consecutive numbers is constant, then it is called as arithmetic progression. Let us see, the difference between 1 and 3 here is 2. In the same way 3 and 5, the difference is 2. The difference here is 2. So I can say that this particular series is in arithmetic progression. Example 3, 7. The difference between 7 and 3. 7 minus 3 is what? In order to find the difference, we have to do what? Second term minus first term. 7 minus 3 is what? 4. So the difference between 7 and 11 is 4. 11 and 15 is 4. Now in this arithmetic progression, what you should remember is two values. What is that? A. A is nothing but the first term of this arithmetic progression, and the first term of this arithmetic progression and is A, and difference D. D is nothing but the common difference. So the common difference is D. How can we find this D? We can find this D when we subtract second term and first term. So second term minus first term gives us D. Now there are some general formulas in this arithmetic progression. What are those? So general formula for nth term. So nth term general formula in arithmetic progression is A plus n minus 1 into D. So A plus n minus 1 into D, and in the same way sum of the first n terms of this arithmetic progression will be what? Sn is equals to n by 2 multiplied by 2a plus n minus 1 into D. So let us write this in n by 2 into 2a plus n minus 1 multiplied by D, where a is the first term and D is the common difference. Now let us solve some questions on this. So find the ninth term of this arithmetic progression. We have to find the ninth term. So first of all, what we should write? We should write the first term. The first term is given as 5. So A is 5. Now we have to find common difference. Common difference is what? Second term minus first term. So second term here is 2. First term is 5. So 2 minus 5 is what? Minus 6. So the common difference here is 3. Now what we should find? We should find the value of ninth term. So ninth term is nothing but A plus, in the place of n, nth term, the formula for nth term is A plus n minus 1 into D. In the place of n, we have to substitute 9. So A plus 9 minus 1 multiplied by D, which is the value of A is 5 plus the value of 9 minus 1 is what? 8. The value of D is 3. So 5 minus 3 8s are 24. So the ninth term is nothing but 19. So the ninth term is what? 19. Now coming to the next question, which is find the sum of 6 terms. So we have to find the sum of the first 6 terms of this progression. First of all, the first term here is minus 1, and the difference here is second term minus first term. Second term minus first term. Second term is 2. First term is minus 1. So 2 minus 1, 2 minus of minus 1 is plus 1, which is 3. So the common difference here is 3 and the first term is minus 1. What we have to find? We have to find Sn. So we know that Sn is nothing but n by 2 multiplied by 2a plus n minus 1 multiplied by D. So we have to find the sum of first 6 numbers. So 6 by 2. 6 by 2 is what? 3. 3 multiplied by 2 into the value of a here is minus 1 plus n value. The value of n is 6. So 6 minus 1 is what? 5. The difference, common difference is 3. So 3 multiplied by 2 into minus 1. So minus 2 plus here 5 3s are 15. So 3 into 15 minus 2. 15 minus 2 is what? 13. So the sum of these 6 terms is 13 3s are 39. So sum of these all 6 terms is 39. Now coming to the next type of progression is, so the next type of progression is geometric progression. So geometric progression is nothing but, geometric progression is a sequence of non-zero numbers where each term after the first term is found by multiplying the previous one with a non-zero number, which is called as common ratio. In the previous progression, which is arithmetic progression, we have common difference. We have common difference. Now in this geometric progression, we have common ratio. We have what? Common ratio R. So the common ratio R is find out. So in the previous video, we have been adding. So we have been adding common difference. Now in this geometric progression, what we will do is, for suppose our first term here also is A. The second term will be A into R, A multiplied by R. And the third term will be A into R square. So I am multiplying R whenever I am going forward. So in order to find the rth term or the common ratio R, what we should do here is second term divided by first term. Second term divided by first term. So let's see the example here. So 2 by 3, 2, 6, 18 are in geometric progression. We have to find the rth common ratio here. So common ratio R is nothing but second term here is 2 and the first term here is 2 divided by 3. So 2 and 2 gets cancelled. So the common ratio for this sequence is what? 3. So the common ratio is 3. So in this geometric progressions also there are some formulas. What are those? So the formula for nth term is what? A into R to the power of n minus 1. A into R to the power of n minus 1, and sum of the first n terms. So sum of first n terms, Sn is, the sum of Sn is A into 1 minus R to the power of n divided by 1 minus R, where R is not equal to 1. So R should not be equal to 1. So where sum of these terms will be A into 1 minus R to the power of n divided by 1 minus R. And if the series is going on till infinity, so in geometric progression there is an infinity question also. If the series is going till infinity, then the sum of those infinite terms is nothing but A by 1 minus R. So A by 1 minus R is the sum of infinite terms. Now coming to the questions. So find the geometric progression. Find the sum of, we should find the sum of geometric progression 10, 30, 90, 270. So first of all, we know the first term is 10. Now we have to find common ratio. Common ratio is nothing but second term by first term. The second term here is 30 and the first term is 10. So 30 by 10 is what? 3. So the common ratio here is 3. Now what we have to find? We have to find the sum of these terms. So there are how many terms? 1, 2, 3, 4. So we have to find S4. We have to find S4. Now we know the formula for sum of terms in geometric progression, which is A into 1 minus R to the power of n divided by 1 minus R to the power of n. So let us substitute the value of A here is 10 into 1 minus the value of R is 3 and the value of n is 4 divided by 1 minus 3. So 10 multiplied by 1 minus 3 to the power of 4 is what? 81 divided by 1 minus 3 is what? 1 minus 3 is 2. Now let us see. So 81 minus 80 is what? Minus 80. This one is minus 2. Okay, in denominator we are getting minus 2. So in numerator we are getting 10 into minus 80. 10 into minus 80 by minus 2. So 2 gets cancelled. 240 is 80. So the sum is what? 400. So our sum is 400. Now coming to the next question, which is find the 10th term in this geometric progression. In this geometric progression, A is 2 and the common ratio is what? 4 upon 2, that is also 2. The first term is 2 and the common ratio is also 2. Now what we have to find? We have to find the 10th term. So we have to find the 10th term. So 10th term is nothing but A into R to the power of 10 minus 1. So here the value of A is 2 and the value of R is also 2. 10 minus 1 is 9. So our answer is what? 2 to the power of 10. So the 10th term of this sequence is 2 to the power of 10. Now the rth term of the arithmetic progression, we have to find the rth term of the arithmetic progression whose sum of the first n terms is given as. So here he is giving the Sn value, which is sum of n terms. So here Sn is given as what? 2n plus 3n whole square, 3n square. Okay. Now let us take n value as 1. So if I have one term, so our first term, that is equals to, sum will be what? Yes, 1. Then 2 into 1 plus 3 into 1 square is 1. So 2 plus 3 is 5. So, or I can say this is the first term of our arithmetic progression. So here the value of a is what? First term. So value of a is 5. Now if I take the value second terms, two terms, then Sn sum of these two terms will be what? 2 multiplied by 2 plus 3 into n square means 2 square. 2 square is 4. That is equals to 2 2s are 4. 4 3s are 12. 12 plus 2 is 14. So this is the sum of what? This is the sum of first term plus second term. First term plus second term. We know the first term. The first term is what? 5. First term plus second term is 14. So after solving this, I can say that our second term is what? Second term is 14 minus 5. 14 minus 5 is 9. Second term in our arithmetic progression is what? 9. So the formula for second term, the formula for second term in arithmetic progression is a plus d. A plus d is 9. So if a plus d is 9, then we know the value of a. So 5 plus d is equals to 9. Then the common difference of that arithmetic progression is what? 9 minus 5, which is 4. So 9 minus 5, which is 4. Let us see once again. So 4 3s are 12. 12 plus 4 is 16. Sorry, the value here should be not 14, but it should be 16. So if this is 16, then the second term will be what? 11. So not, this will not be 9. It will be what? It will be 11. So if a plus d is 11, this value is 11. 11 minus 5 is what? 11 minus 5 is 6. So the common difference here is what? The common difference here is 6. These values are 16. Now what we have to find? We have to find the rth term. So we know that rth term is nothing but a plus r minus 1 into d. So the a value here is 5 and the r minus 1, the d value here is 6. So 5 plus 6r minus 6. So the rth term of this arithmetic progression is 6r minus 1. So our answer is option C. Now coming to the next question, which is the third and fifth terms of arithmetic geometric progression. The third and fifth terms of geometric progressions are respectively the second and eighth terms of arithmetic progressions, whose first term and common difference are both equal to 16. So here he is telling that in arithmetic progression the first term is 16. In the same way, the difference, the common difference is also 16. The common difference is also 16. So let us write the statements in equation form. Here he is saying that the third term is nothing but the second term of arithmetic progression. The third term in geometric progression. Third term in geometric progression is nothing but a into r to the power of n minus 1, where n is 3. 3 minus 1 is 2. So a r square is nothing but is equal to the second term of arithmetic progression. Second term of arithmetic progression is a plus b. So let us write this value as a1, because the value of a here is in the arithmetic progression, a1 is in geometric progression. So a1 r square is given as a plus d. A is 16. 16 plus 16 is 32. So the value of a1 r square is 32. So let us keep this aside. And the fifth term in geometric progression is equals to the eighth term in arithmetic progression. The fifth term in geometric progression is a into r to the power of 4 is equals to eighth term in arithmetic progression. Here a1 and 70, a plus 70. Eighth term is 8 plus a plus 70. Now a1 r to the power of 4 can be written as a1 r square multiplied by r square, and the value of a is 16 plus 7 into value of d is 16. So we know the a1 r square value. A1 r square is 32 into r square is 16 into, let us take the number 16 common, then I'm left with 1 plus 7. 16 into 1 plus 7 is 8. 16 into 8. So 16 ones, 16 2s are 32. 2 1s are 2 4s are 8. So r square here is what? R square is 4. Then the value of r is 2. So common ratio is 2. So we know that a1 r square is 32. So a1, the r square value is what? 4. then 32. A1 multiplied by 4 is equal to 32. So 4 ones are 4, 4 ones are 4. Now 4 8s are 30. So sorry, 4 8s are 30. So our A1 or the first term in our geometric progression is what? The first term in our geometric progression is 8, which is option 1. So here he has asked for what is the first term in geometric progression. So our answer is option A, which is 8. Now coming to the next question, which is the if the first and sixth terms of geometric progression are 2 by 3 and 162. So the first term in geometric progression is A. It is given as 2 by 3. And the sixth term is nothing but A into R to the power of 5. It is given as 162. So we know the value of A, that is 2 by 3. 2 by 3 multiplied by R to the power of 5 is 162. Then R to the power of 5 is nothing but 162 multiplied by 3 divided by 2. Now 2 ones are 2 8s are 16, 8 1 2 ones are 2. So R to the power of 5. 81 can be written as what? 81 can be written as 3 to the power of 4 multiplied by 3 to the power of 1. So R to the power of 5 is nothing but 3 to the power of 5. Then the value of R is what? Then the value of R is 3. Now what we have to find? We have to find the 8th term of this progression. So 8th term of geometric progression is nothing but A into R to the power of 7. So the value of A is 2 by 3 into the common ratio here is 3. So 3 to the power of 7. This will become what? 2 into 3 to the power of 6, because this 3 will be cancelling 1 3 above. So our answer is 2 into 3 to the power of 6. So 2 into 3 to the power of 6 is what? 3 cube multiplied by 3 cube. 3 cube is 27. 27 into 27 is what? 729. So 729. So 729 multiplied by 2. 9 2s are 18. 2 2s are 4. 1 5. 7 2s are 14. So our answer is what? 1458, which is option D. Now coming to the next question, which is 3 numbers are in arithmetic progression and their sum is what? Given that their sum is given as 3. So let us take the term as A. So the next term will be what? A plus D, and the before term will be what? A minus D. This is the first number, this is the second term, and this is the third term. So he said that the sum of these three numbers is given as 3. So the first number is A minus D, then the second number is A, the third number is A plus D. It is given as what? 3. So D plus D and minus D gets cancelled. So 3A is equals to 3. Then the value of A is what? Then the value of A is 1. So the value of A or the number A is 1. Now coming to the next condition, which is the third number is greater than the first number by 16. So he is saying that 3 minus 1, the third number minus first number is 16. So let us write. So A plus D is the third number minus first number is A minus D is equals to 16. After solving, I am getting 2D is equals to 16. Then the common difference is what? 8. The common difference is 8. So if the common difference is 8, now I can find the numbers individually. So A is 1, common difference is 8. 1 plus 8 is 9. In the same way, 1 minus 8, our first number is 7. Now in this question, he asked for the product of these three numbers. So the first number is minus 7, the second number is 1, and the third number is 9. So our answer is what? 7 9s are 63, that too minus 63. So our answer is option A. Thank you very much for watching this video.